SIP9 Hub.
Welcome to the 9th episode of our series on mathematical language and symbols. In the previous video, we started talking about functions, and in this presentation, still on the topic functions, but this time, it will be specific on function evaluation.
But before we continue, do not forget to like this video, hit the subscription and notification bell to stay updated of future videos.
Function evaluation is just the process of identifying the image of a certain element in our domain. Put in other words, this is the process of identifying or computing the value of the function at a specified point. Suppose we are given this function. Take note that we can name our function this way. F of x. This is read as f of x. F is the name of the function, and this expression here tells us that the independent variable is x. And when we evaluate the function, we are going to simply change that independent variable to a particular value. For example, f of 2. What do we mean by this expression? We are going to compute for the value of the function f if we set x equal to 2. This is the same as saying that we are going to substitute 2 to all x in the right hand side of our function. So we have 2x, but if we evaluate, if we substitute 2 to x, then it becomes 2 times 2 plus 1. The value of the function at x equal to 2, or that is f of 2, is simply 5. The same function, but we are going to evaluate it in another point, that is at x equal to negative 3. So simply, we are going to substitute negative 3 to our function to the right hand side of the function. And that is 2 times, instead of x, we change it to negative 3. So we have negative 6 plus 1, that gives us negative 5. For our next example, we are talking about the same function, but this time, our input, we sometimes call this our input. The value that we substitute, that's an input, or that's the point. Our input is an expression, but the process would still be the same. That expression 2a plus 1, that's the quantity that we're going to substitute in place of x in the right hand side of our function. So we proceed as follows. 2x, that's the original function, but this time we let x equal to 2a plus 1. So 2 times the quantity 2a plus 1 plus 1. If we simplify this one, we have 4a plus 2 plus 1. How did we get 4a plus 2? We multiplied 2 to both of 2a and 1. So that is distribution. We can simplify 2 and 1 as 3. The sum is 3. For our next example, we are given a different function. The name of that function is g. Our independent variable is still x. This time, we're going to compute for g of 3, or the value of the function if we substitute 3 in place of x. We follow our function, so we have 3 times. Instead of x squared, we change x to 3, so we have 3 squared. Minus, this is minus x, but instead of minus x, we change that into 3, so we have minus 3 plus 1. Simplifying, 3 squared is 9, and negative 3 plus 1 is negative 2. Multiplying 3 and 9, we have 27, and if we subtract 2, the result would be 25. The same function, but we are going to evaluate g of negative 5. This means that we are going to identify the value of the function if we change all x's in the right hand side of the function to negative 5. We proceed as follows, and we see that the final answer is 81. Another one, what if we are going to substitute an entire expression to our function? So for x, instead of just x, we change it to x plus 1. So this becomes quantity x plus 1 squared. Minus, also, we change x to x plus 1. so it becomes longer now. We can expand this quantity. This is a binomial. We want to square it. If we do that, we have x squared plus 2x plus 1. And then, for the second term here, we can distribute the negative sign in the two terms of this expression. So we have negative x minus 1. It becomes minus 1 because negative 1 times positive 1 is negative 1 plus 1. The next step is to multiply 3 to all the terms here, the 3 terms of this expression. So we have 3x squared plus 6x plus 3. Minus x, this is simplified as 0. Negative 1 plus 1 is 0. We can further simplify this one as 3x squared plus 5x plus 3. What did we do? We have 6x, positive 6x minus x is the same as 5x. Let us have function composition. Function composition is just similar to function evaluation. However, this time, the value being substituted or our input is another function. This is our notation. This is read as f of g. This is the function composition between functions f and g. And this is read as f of g. This means that the function at the rightmost side serves as our input to the function f. Let's provide an example for this one. We have two functions, f of x and g of x. And what we mean by f of g is to take our function g of x and then use it as an input to the function f. And why is that? It's because the functions are arranged this way. It's the function at the rightmost side that becomes an input to the function that is next to it. So to compute, we proceed as follows. Remember that f of x is x squared minus 1, but we change x to the value of g of x. That's why we see 3x plus 1 squared minus 1. Expanding this binomial, we have 9x squared plus 6x plus 1 minus 1. Simplified as 9x squared plus 6x. That's because 1 minus 1 is just 0. That is an example of a function composition. Let's compute another one, this time g of f. In the first example, we computed f of g, but this time we are going to compute the reverse, g of f. Meaning, f now becomes our input to function g. What is function g? It's 3x plus 1. But our input is the entire f of x, so we change x here to x squared minus 1. That's what we see here. We can simplify this one by distributing 3 to both of the two terms here. So we have 3x squared minus 3, you have plus 1. Simplified as 3x squared minus 2. That's it, function evaluation and composition of functions for our last presentation on functions. I will see you in the next video.